Today's focus is the quadratic formula. We already know how to solve for x using other methods. For example, we just recently learned about the square root property, saying that if you want to solve for x, you first need to isolate the term that's being squared. So that gives me 4x squared equals 32. Divide each side by 4. That gives me x squared equals 8. To get the x by itself, you undo the square, taking the square root. That gives me x equals plus or minus square root of 8. You are supposed to simplify your radicals. If you think about the factors of 8, 1 and 8, 2 and 4, 4 is a perfect square other than 1, so you could rewrite the square root of 8 as the square root of 4 times 2. The square root of 4 is 2. The square root of 2 does not simplify, so plus or minus 2 root 2 there. You also could use the square root property if you have a quantity being squared, so subtract 18 from each side. That gives me negative x minus 6 squared equals negative 9. Divide each side by negative 1 to get what's being squared by itself. Undo the square, taking the square root. X minus 6 equals plus or minus square root of 9 is 3. Add 6 to each side. Don't forget, you need to write this as two different things. A positive 3 plus 6, a negative 3 plus 6. So that gives me 9 and 3. We also know how to solve by factoring. So this is a trinomial where a is 1. I can do guess and check, 1 and 33, 3 and 11. Because it's positive, using same signs to get negative 14 when it adds. This is your factored form. Set each part equal to 0. It gives you your solutions of 3 and 11. Or here, this is a GCF problem where the GCF is negative 3x. Pull out a negative 3x, divide each term by that. You get x minus 7. Set each part equal to 0. That gives me x equals 0 and x equals positive 7. So those are the two methods we already know. Now we're going to do the quadratic formula. Just so you know, square root property, what we were doing here, you can only do when you have something being squared and constants. So square root property does not always work. Factoring. There have been some situations that are not factorable. Factoring does not always work. The quadratic formula will always work. You can solve any quadratic by using this formula, which you should have memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I have the steps written out here, but I'm just going to go ahead and work through these steps as we go through some examples. So step 1, what you're going to do is you are going to put the equation in standard form. You always want to make sure that it's in standard form, highest to lowest power, and it's set equal to 0. So if I were to approach this problem, I personally like it when my leading coefficient is positive. So I would probably add the x squared, add the 4x, and subtract the 30. So that way everything cancels on that side. I get 0 equals x squared. Combining like terms, 1 plus 4 is 5x. And then 1 minus 30 is negative 29. You don't have to have a positive leading coefficient with quadratic formula. It's just a personal preference. Now, with standard form, a is always a number in front of the x squared, so a is understood to be 1 here. B is the number in front of your x to the first power, so that's 5. And c is your constant. Keep that sign, it's negative 29. What you're going to do is you are going to plug a, b, and c into the quadratic formula. So x equals negative b plus or minus the square root, b squared minus 4 times a times c all over 2 times a. When you simplify this, I would first simplify what's called the discriminant, which is the part that's underneath the radical. So don't plug in the square root, just plug in what's inside of the square root. So I would plug in 5 squared minus 4 times 1 times negative 29. Hit enter. That gives me 141. And 2 times 1 is 2. So now I'm like, okay, I need to simplify the square root of 141. If I try it to see if I get a whole number, I get a decimal. So 141 is not a perfect square. That doesn't work. If I'm thinking about the factors of 141, It's 1 and 141, 3 and 47. And that's it. So I don't see any perfect squares other than 1 here, which means that radical does not simplify. So this is just your answer right here. We stop. If you could simplify the radical, you would keep going, but this does not. Let's do another one. First, I need to get this set equal to 0, so let's go ahead and subtract 5 from each side to get 3x squared plus 2x minus 5 equals 0. So A, the number in front of x squared is 3. B, the number in front of x to the first power is 2. C, your constant. Plug it in. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. And then we're going to simplify this. So underneath the radical, I have 2 squared minus 4 times 3 times negative 5. So that gives me the square root of 64 over 6. Now, I believe square root of 64, perfect square, you get a whole number. So there's no more radical. You've evaluated it. You get the whole number 8. So it's negative 2 plus or minus 8 over 6. When you can simplify the radical, you do keep going. These are all like terms now, so I can branch it off and say the 2 different answers. That plus or minus belongs only to the 8, so it's negative 2 plus 8 over 6, negative 2 minus 8 over 6. And then I got negative 2 plus 8 is 6. 6 divided by 6 is 1. This gives me negative 10 over 6, which does simplify to negative 5/3. Example 3. For example 3, it's already set equal to 0. A is the number in front of x squared, that's 3.5. B, I'm missing an x to the first power, so B is 0. And C is negative 7. So I guess I should have wrote that there. Let's go ahead and plug it in. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. In my calculator, let me plug it in. 0 squared minus 4 times 3.5 times negative 7. That gives me 98. So that's x equals negative 0 is just 0 plus or minus square root of 98 over 2 times 3.5 is 7. Now you could check, but I already know 98 is not a perfect square. You're not going to get a nice whole number like the previous example up there. So I need to think about factors of 98. 1 and 98, 2 and 49, 7 and 14. So 49 is a perfect square, which means I can simplify this. The square root of 98 becomes the square root of 49 times 2. The square root of 49 is 7. Square root of 2 doesn't simplify. So that just gives me 0 plus, which that doesn't do anything. So I'll just do plus or minus 7 root 2 over 7. If you have the same thing in the numerator and denominator, they cancel. So I just get plus or minus root 2. And that's it. That's your answer. One more. It is already set equal to 0, so I don't have to manipulate it there. A, the number in front of the x squared is negative 1. B, the number in front of x to the first power is negative 8. I'm missing a constant, so my c value is 0 this time. Plug it in. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. So negative 8 is a positive 8. We know 2 negatives makes a positive. Make sure you're putting your negative 8 in parentheses in your calculator. Otherwise, you're going to get the wrong answer. So minus 4 times negative 1 times 0 gives me 64. Over that's 2 times negative 1, so negative 2. This is a perfect square of 8. So I'm going to get a whole number. It's 8 plus or minus 8 over negative 2. Because they're all constants, remember you can branch it off. So 8 plus 8 over negative 2, 8 minus 8 over negative 2. This gives me 0 divided by negative 2, or 0. So that one's pretty easy. This gives me 16 over negative 2, which is negative 8.